Assalamualaikum warahmatullahi wabarakatuh. My name is Jihan Nabila Fitrasani with student ID as 2206031366. Here I will answer the third task and the final task, which is to solve a problem of optimization using die 5. So without further ado, so I'll explain. So there's a farmer that has 600 feet of fencing and wants to create a rectangular field along a river. He needs no fence along the river itself. What are the dimensions of the field that has the largest area? So since we need to know what optimization first is, so optimization is a process that which main objective is to get a maximum output with minimum input. So with that in mind, we can get into the die 5 steps. So I will not explain what die 5 is again because I've explained it many times before from my previous videos from the early of this semester. So I'll just get into what each point of die 5 will be filled with. The first one is intention. So in this problem, our intention is to be required fulfillment for our Lord, which is a must. By solving this problem, which is to find optimum results within the parameters given, which in this problem is the dimensions of the field. Okay, and after that we can continue to the second point of initial thinking. So in initial thinking, we will try to obtain the nature of the problem, which is the principles of the problem basically. And in this part, we can do two steps of to do. First, break down each given information, which we can see from these problems that we have a rectangular field, and then the fencing, and then it is also placed along the riverside. So it's the riverside, the riverside, and then we can get into the properties in the problems, which is we have 600 foot of fencing, and then no fence along the river, breadth of the rectangle and length of the rectangle because the field is in rectangulars. And we can get into the third point, which is idealization. In idealization, we have a few steps to do, which first to make assumptions of properties values, and then make the model of the problem, and then verify or validate whether the assumptions and model made are right. So the first one, we can try to make the model here, which is it was said that the wants to create a rectangular field along a river. He needs no fence along the river itself. So this is the river and this is the rectangular field. Since we don't need the fencing around the river, we will only have this side, the length, two length and one breadth, since we won't need to put fencing along the rivers. And then we can get into assumptions, which is to put values into the properties that we have, such as maybe we have bread and we can use x to represent it, and then as length we can use y to represent it, and then the perimeter which was said is 600 feet, okay, of fencing. So which perimeter we will symbolize as p is 600 feet, and the constraint is perimeter of the field because this is the constraint, right? And so because in idealization we also try to decide what formula to use or software to use to solve the problem. Since we will be using manual computing, we will try to find a formula that can decide whether the answer will be right or wrong. So with the formula, as for the constraint formula is P equal to x plus 2y. Why? Because this is the perimeters, and we can just add up the length, which is 2 length, that's why we multiply it by 2 of length, and plus the breadth because there's only one side of breadth. And then there's another formula to use, which is the objective functions, which we will use as area function, and this formula will find the biggest area we could get within the constraint. And then we will try to verify or validate whether the assumption and model are right. Because the functions used has all the value needed, it can be concluded that this point is clear, and we can go to the next point. So we can go to the next point, which is the last point. It's instruction. In instructions, we do it to get specific results by substituting the value from assumptions to the equations that we have chosen. First, we have the constraint function, which is this, and we can substitute the value from the assumptions that we have made, which is P is 600 feet. That's why we put 600, and then x plus 2y. So we will try to look its value of x and y, specific value of x and y. So we can move the to y beside the 600, so we can get the value of x. And then because we have the objective function, which is a of the area function is x multiplied by y, we can put a equal x multiply by y, and then a equal to 600. We put x, this value of x, which is 600 minus 2y, into the area functions. So we get 600 minus 2y multiplied by y, and then a will be 600y minus 2y squared. And then we will derivate this to get the specific value of y, and the derivative of this will be 600 minus 4y, and we assume it's equal to 0, and so 600 equal to 4y, and y will be 600 divided by 4, which is 150. So we get the value of specific y, which is 150 feet, and from that from the value of y, we can get the x value, which we will just substitute from this part, from this formula that we have gotten, and the x value will be 300. And to get the maximum area, which we will just use the area function or the objective function, and we can get the maximum area of 54,000 square foot. So the answer to this question is, what are the dimensions of the field that has the largest area? So the largest area is 45,000 feet square feet, and the dimensions of the field is 300 multiplied by 150 feet. That's all for the third task of this last task before finals exams. Wassalamualaikum warahmatullahi wabarakatuh.